Hello everyone, my name's Brad. I work for the University of Waikato in New Zealand, and I work on an open source SDN controller called Faucet. And today we're going to be talking about the Faucet controller, how it can control enterprise networks, and how you can use Faucet to validate switch hardware OpenFlow implementations. So I just wanted to start with this sort of picture, which kind of sets the example of an enterprise network, sort of copper cables strewn everywhere that allow our users, whether they're on their desktops, laptops, or cell phones, to connect back to the corporate sort of enterprise network. And so there are a number of unique networking requirements that sets enterprise networks apart from others, such as data center or telco environments. So we have a large number of users spread out over a large geographic area and on a number of different network segments and kind of different buildings and that kind of thing. We want to provide a consistent and good, fast, reliable experience for them wherever they are and whatever device they're using. And we kind of need really good network visibility to do that. Security is a big deal these days, so we need to be able to enable flexible security policy to properly segment our network. And then we need it to be easy to manage. So that's in terms of rolling out new config, monitoring for any issues proactively, and giving us the tools to help debug our network when things go wrong. And so there are a number of challenges that make meeting our requirements difficult. And so scale is a big problem here, having to manage thousands of switches and wireless APs in a unified manner. We also need to be flexible about how we build our network in terms of topology. We have to work around sort of a complicated mess of different buildings with different sizes and layouts and that kind of thing. And they've all got kind of limited physical cabling constraints, so different amounts of cabling inside the building and between buildings that we need to work around. And we often have no control over the devices that connect to us. So BYOD, bring your own device, is very popular these days. IoT sensors, increasingly smartphones as well. We need to be able to support them on the network and whatever network protocols they speak. And so when we started the Faucet journey in about 2014, there weren't many mature SDN controllers at all, certainly none ready for enterprise. And so we did the hard thing of writing our own. And so a bit of an overview of what Faucet is. So we call it a lightweight SDN controller. So it's lightweight in terms of number of lines of code, so between 10 and 15,000 lines of Python. And it runs on low resource compute, so Raspberry Pis and that kind of thing. It uses the OpenFlow 1.3 standard to program rules and devices. And you can think of it like a layer 2, layer 3 switch. It does forwarding and routing at the end of the day. And it's kind of built to these requirements that we just covered. And so what are the useful features that makes Faucet useful in enterprise? So early on when we were writing Faucet, we didn't want users to have to write code necessarily to change the functionality. So we've got lots of very fine-grained policy that you can add on top of Faucet to sort of augment what the default features do and build your own functionality. We also have this notion of stacking, which is when you amalgamate multiple switches into one kind of administrative domain inside Faucet. And we run a number of different algorithms for doing path selection inside that cluster of switches. This allows us to build very flexible topologies and ones that are resilient. They've got multiple paths around the network so that kind of switches or paths can, cables can die and the network keeps going. We do all this without running a distributed protocol like spanning tree because we have a kind of like a central view of the network, which is also great for other things like managing the network and having good monitoring visibility. There's one point where the data comes into and it's all kind of in a sane and unified format, which is nice. We support 802.1x auth, and we've been doing a lot of recent work on LACP and multi-chassis lag. So once again, around allowing devices to connect via multiple paths to the network so that you have no single points of failure. And Faucet uses this OpenFlow standard that's been around for a while to program sort of rules into hardware to define the network behavior. So specifically, we're using a subset of version 1.3. We're only using features that work well on low-cost ASICs, and we're not using any vendor extensions. So we're just using the pure OpenFlow spec, and we use OpenFlow the same way on every device, so that every device has a level playing field when talking to Faucet. Devices that do have programmable ASICs with redefinable pipelines, we use the table features message to define a sort of Faucet packet processing pipeline, if you will. And down the right-hand side of this slide is a sort of example of the different stages of our pipeline that Faucet might put in a switch. And now, depending on which features you got enabled, you might get simpler pipelines than this, because Faucet always tries to use the smallest amount of hardware resource on the switch possible. So device support for Faucet is pretty good at the moment. So we've got 5 different hardware vendors that support Faucet and their device families. And so 3 of these kind of existed before Faucet, and we've just partnered with them and made sure that the specific Faucet features work well on their devices. And that's Aruba, Allied Telesis, and NoviFlow. And then we've had 2 brand new people write OpenFlow implementations, basically from scratch, to work with Faucet. And those are Cisco and Arista. And so we've worked closely with the engineers there, who have been absolutely brilliant. And we've helped them, and they've helped us. It's been quite a nice relationship. And of course, we're always looking to add more vendors to the Faucet family. That's kind of the purpose of the talk today, to make people aware of what we're doing and that we're here to help you write OpenFlow. And specifically, kind of white box device vendors would love to talk to you. So Faucet's supported on a number of different ASICs. We've seen it on a number of different Broadcoms. Aruba's using their ASIC, Cisco's got their ASIC, and then NoviFlow they wrote a version of OpenFlow in P4, which lets Faucet talk to a Tofino switch, and they've also got a number of MPU switches that we can control. And so how can we help you? So we've got a very nice user community with real deployments of Faucet all around the world, and they're more than keen to put more devices on the network. We're kind of a really good real-world example of how you can use the OpenFlow specification to build a network controller, and it's kind of a good real-world use case. And Faucet also provides a very comprehensive test suite. And so this test suite's useful for a number of things. So 1, it helps us make sure every time we write new Faucet code that we know it's working. But 2, you can also run the test suite on real hardware switches and a number of different network topologies and scenarios with various different features turned on. And we'll put real packets through the switch and make sure that they get sent to the right place, dropped, allowed, whatever. And a number of vendors are using the test suite to QA basically their firmware releases. And some vendors have used the test suite to help write their OpenFlow implementation. And so what kind of things do we test for? Well, namely, we started testing, actual Faucet functionality to make sure we don't get it wrong. So we test, broadcast only goes inside the same VLAN domain. It doesn't go between VLAN domains. We test that hosts can move between sort of untagged ports, and that all works. But then we've also sort of added over time OpenFlow feature tests. So where the set fields lets you change a part of the packet that you can match on, say, the DSCP bit and that kind of thing. And these are kind of just examples of the tests that we've got. We also kind of track common problems or strange problems we see and encounter in different devices. And when we see those, we add a test so that we can make sure that problem never happens again. And I think definitely the strangest test we've added is this untagged NS loop test. And that's based around this device we had that when you gave it an IPv6 neighborhood solicitation packet, it would kind of cause that to loop around the network a little bit and cause a packet storm. So now we've got a test to make sure no one else makes that same mistake. And then we also have negative tests that we expect to fail, like producing a bad OpenFlow flow message and making sure the switch produces an error. Running the test suite's pretty easy. We've got some documentation there. All runs in a nice Docker environment, so it's easy to run anywhere. And as I said before, yeah, we're always here to help and would love to engage with people looking to implement OpenFlow. And so here's our kind of website and documentation. We've got a tutorial series there for playing around with Faucet to see the different features it has. And there's my email address if you need to get in touch. So thank you for listening.
All right, so Brad here. Don't have any questions, but thank you all for listening. So I see a question from Dan Pitt. Hi, Dan. Good to see you. So how does Faucet scale to enterprise size? So we've made a number of key assumptions in sort of designing the product to make sure it is very efficient. And we, as I said, with the test suite, we verify that it can learn thousands of Macs and have no issues. So we've tested that a whole bunch. And you can also shard faucets. So if you have a very large layer 2 segment on your network, you could run multiple faucets to control that segment. And so we've got a couple of different ways to mitigate large networks. I'm happy to take any other questions if there are any. Otherwise, thank you all for listening in. And feel free to get in touch with me via email if you have additional questions. Always happy to answer.